All right, so if you were absent Friday, do watch the lesson. It's only a few minutes long, really. It just takes that long to do a few examples. So that's what we did, is fill out this part of the notes. That is also uploaded to Schoology under last week's folder if you need that to copy into your notes. But basically, we just did a few examples. We learned what domain and range are. So what does domain refer to? What does range refer to? So range is all your Y values, domain is all your X values. So in other words, domain is all your inputs, range is all your outputs. What's an easy way to remember that? Dr. XY. So that'll help you remember that domain is asking you what are all the X's, range is asking you what are all the Y's. So we looked at identifying domain and range from ordered pairs. Hopefully that's straightforward. From a table, from a map, and from a graph. So a few examples of that if you missed Friday or you just need some more review. Today we're going to look on the other side of this paper for domain and range of continuous graphs. So if you had me in algebra first or third hour, you should already know. But what are these types of graphs called on this page? Discrete. Good. If you want to write that in, maybe on this side, go ahead. These types of graphs are discrete because they're dots. They're not continuous. All right, so taking domain and range of discrete graphs basically just looks like this, right? It's just a list. It's telling me that my X's are -2, -1, 0, 2, and 5, and nothing else. It's telling me that my range is -3, 4, -2, -1. And that just comes from reading the coordinates and making a list. So if you have discrete graphs, that's what your domain and range will look like. When you have continuous graphs, it's a little bit different because you have basically a lot more things that X or Y could be. So for the domain is all of our what? Good, so Dr. XY is all of our X's. So to figure out what our domain is of continuous graphs, you scan your pencil from left to right along the x-axis. The x-axis goes from left to right. If you're told to find the range of a continuous graph, what is range? So we're going to look along the y-axis. So you're going to scan your pencil from top to bottom or up and down, whatever, but top to bottom along the y-axis. All right, and then if you want to put this like somewhere maybe in the margin, for every boundary, use an inequality symbol. All right, so that'll make sense once we do a few examples. But if there's like a boundary, you use an inequality symbol. So instead of saying like how on the first page, X is this number or this number or this number, now it's like X is greater than 5. X is less than or equal to 7. Like it just depends on the graph. So questions on these definitions so far? All right. So let's look at the first example. So domain, we're looking at what axis? All right, Dr. XY, so domain, we're looking at what axis? The X. So looking from left to right, see like how the graph is. Does it look like it'll touch all the x's to the left? Also look at the arrows. The arrows mean that it goes on infinitely. So eventually, will it touch all the x's on the left? Yes. It'll continue to keep going, but infinitely, like it will touch all the x's to the left. So there's no boundary to the left. Is there a boundary to the right? No, it looks like this also goes infinitely toward the right. So in that case, my domain, when there's no boundary, is going to be all real numbers. All right, that means there's no boundaries at all. So X is all real numbers, the domain, because it'll eventually touch all the x's because it keeps getting wider and wider infinitely. Questions on that? Okay. For the range, we scan what axis? So from top to bottom on our y-axis. Now, does it look like the graph will go infinitely upward? Yes, because these arrows, don't they point upward too? Yes, they kind of go out of diagonal. So yes, eventually they'll just keep going up and up and up. Because it has arrows, it goes on infinitely. Does it go infinitely downward? Where does it look like it stops at? What's like the lowest part of my graph on the y-axis? Where does the graph touch on the y-axis, like the lowest most part? At -2, right? So that is going to be included. So every time you have a boundary, you're going to have an inequality symbol. So I'm going to leave some space for the inequality symbol. Guess what letter we're going to use? Y, because ranges are y's. All right, to figure out what inequality symbol, because like I said before, anytime that there is a boundary, you're going to use an inequality symbol. To know which one depends. Are the y's that are on this line greater or less than the -2? So as you go up, the y's get bigger. So yeah, the y's are greater than -2. Does it touch the -2? Yes, it has a solid line on the -2. It does touch, so it's also going to be equal to. So we're saying that for the range, it's y greater than or equal to -2. Question? All right. So that might look weird, but we're basically just saying that if I were to pick like every single coordinate off this graph, all the y's would be greater than or equal to -2. All right, let's try a different one. All right, I think that number 2 is good to do as a class. So for the domain, we're looking at what axis? So we're scanning from left to right. Does it look like this graph goes infinitely to the left? Where does it look like it stops at on the x? So -3. Every time we have a boundary, and I probably should write that on the other side. Every time we have a boundary, we're going to have an inequality symbol, just so you know. So -3. Does it look like this graph goes infinitely to the right? Where does it stop at? +3. And then guess what letter we're going to use for this one? X, because it's the domain. All right, that's how I work from it. Look for any boundaries. If there's none, then it's all real numbers. If there are boundaries, and you'll never have more than two, because it either goes infinitely left, infinitely right, or both, so no more than two boundaries, then you're gonna have an equality symbol. So just compare, are the x's on this graph bigger or smaller than the -3? Bigger for sure, so the opening of our symbol should face the x between the -3 and the x. And would you say that on this graph, are the x's greater or less than 3? So like, does it go more to the right or more to the left of the 3? Right, are you paying attention? Hello? Like, if I were to pick any point off of this graph, what would my x value be? Would it be a value that's smaller than 3 or bigger than 3? Less than. Less than 3, because like if I pick, say, like this point off the graph, that's 0, 0, is 0 greater than 3? No, so that's why it's that way. Now, I almost forgot a part. What do I also need to have in here? Or is this complete? Does the graph touch the -3? Yes, we have a solid line going through the -3, so it's also equal to. Does it go through the 3 on the x-axis? So then it's also equal to right here. Questions on that? So basically, when you see like, and we call these compound inequalities, when you see it in this format, we're basically saying x is any number between -3 and 3. That's all it's saying. I know it's like math words and symbols, but like, we're just saying all the x's on here are either -3 to 3. Now do the same for the range, except this time I'll have you do that part on your own or within your teams. I'll give you like 30 seconds, see if you can come up with the range on your own. All right, raise your hand if you think your team knows the range. All right, nobody, so let's try as a class. Is my range going to be all real numbers? No. Does the graph go infinitely up? Does it go infinitely down? So not all real numbers. There's definitely at least 1 or 2 boundaries. How many boundaries do I have? I have 1 where? And then where? Good. So for the range, you look at your y-axis, because range is all your y's. When you scan, the graph never goes past the 3 or the -3. Now you just have to write that with like your math words. What letter do we use for range? Y. Good. And then use the numbers that it stops at. So usually the one on the left will be the smaller one. So -3 to +3. And then figure out what way the symbols go. So compare the y to the -3. Which one should the opening be facing, the -3 or the y? The y, because all of this, all these y values are greater than the -3, so we use it this way. Does it touch the -3? Yes, we have a solid line going through the -3, so make sure you put that equals. What symbol goes between the y and the +3? less than or equal to. Because all the y's on this circle for my line are smaller than 3, or they're 3 exactly. So that's how you know. Question? All right. I'm gonna give you a couple to try. I want you to try number 3. Yeah. Try number 3 and 5. I think those are similar to the ones that we did. That's why I picked those out. Use your team members. I'll give you like 3 minutes. So group 3. For the domain, that's referring to all the what? Group 3. Domain is all of the. Thank you, Kaylin. Domain is all of the exits. So then group 3, are there any boundaries on the X for this line? Yeah. No. And how do you know that? I don't know. Unacceptable. None of you asked. So if you don't ask, then I assume that you guys know. Table 2, what tells you that there is no boundary on the x-axis? What part of it? How do you know it's infinite? The end of it has an arrow. Good, thank you. On both ends, actually. So will it eventually go all the way to the left? Will it go eventually all the way to the right? So then what's my domain when that happens? Table 5. All real numbers. And then here's another way to write it too, just in case you ever see it. It's like an R with an extra line. That's like the shorthand of all real numbers. All right, table 6. What is the range of number 3? So that's Dillinger. Is there a boundary going up or down? So will it go infinitely up? Will it go infinitely down? So then what's my range when it goes infinitely both ways? Barely mouths it, but yes, all real numbers for the range here. So it goes infinitely up and down eventually, right? Once you stretch it all the way out, and it does go on infinitely because it has arrows, it will eventually touch all the y values. So questions on 3? All right, it's only when there's boundaries that you use inequality symbols. So like in number 5, do I have any boundaries on the x-axis? Or does this graph go infinitely left and right? How many boundaries are there? 2. At what numbers? Good, so everyone see that? That means that when I'm making my, or listing out what my domain is, I look at where it stops on the x, which is at -1 and at +5. So I'm gonna have 2 inequality symbols. What letter do I use for domain? So we'll put an X in the middle. And now compare. Is this square that's drawn on there, would those X values be greater than the -1 or smaller than it? Greater, because the more to the right, doesn't the numbers get bigger? And so compared to this boundary at the -1, this line is to the right. So the X would be bigger, so put the opening for the X. Does it touch the -1? So then equal to also. What about between the X and the 5? Is what's on the square bigger or smaller than the 5? Smaller, because it's to the left of the 5, isn't it? Yeah. So less than. Does it touch the 5 right here where the blue is? So then also equal to. If you notice, anytime it's a compound inequality, if you put like the smaller number on the left and the bigger one on the right, it'll always be less than or equal to. So there's a little tip there. As long as you put it like smaller on the left, bigger on the right, it'll always be less than or equal to. Unless it's like a dotted line, but there you go. What about the range? Are there any boundaries on the y-axis for this? Well, I just did the line the first time. Yes, how many boundaries? So here and here, when you scan from up and down, here's the uppermost part, here's the lowermost part. What y value is the uppermost part? A +3. What's the lowermost y value? -3. What letter do we use for the range? What symbols will go in between? Less than or equal to. As long as I put the smaller number on the left and the bigger one on the right, it'll always be less than or equal to. Okay, questions on that? All right, now let me explain to you what you are doing tomorrow. So if tomorrow you forget, you can watch this video. It would be like the last few minutes of the video. You're doing this domain and range cutout puzzle. You can do it with a partner, literally just one person as a partner. But either way, like I'm gonna have enough that you could all do your own. Either way, you're all responsible. So don't put your partner's name on your paper if they aren't doing anything. You don't have to work with someone if they're not pulling their weight. So listen, basically you'll be given 2 papers, one that looks like this and one that looks like this. You have to identify the domain and range of all those examples. So listen, stop talking over me. You identify the domain and range of all of these examples, and then you kind of piece them together like a puzzle. So let me see if I can show you without showing you an answer. When you list the domain and range of, say, like this one, you are connecting it like a puzzle with another piece. So like, let me read the instructions up here. It says cut the squares apart and arrange them so that the edges match. Paste the squares on the template in the correct order. So once you've identified your domain and range, it should match with another one. So let me just kind of let you peek at the key so you won't see more than the first row, and you would paste it onto here. So I'll help you with the first row. So once you graph it, or once you identify your domain and range, you piece it together with its matches. So for example, the range of E is -2 less than or equal to Y less than 1. And you know, because that's an open circle right here, that it's less than. None of the domain or ranges will match this one, so that's why it's an edge. Down here, the domain for K is all real numbers, so it matches with F on the bottom and so forth. So like you're piecing together based on the domain and range. Does that make sense? So once I fill this out, I should be able to find the part that matches and piece it together like a puzzle. I'll leave a key with a sub, and you would have to like literally come up and compare. I'm not going to put it on the wall right there like I normally do. But yeah, so you can get like hints from the sub, but you shouldn't be copying. I'll make sure that she's aware of that, and it'll be due at the end of the hour. So like you have the first row here, E, K, and B, and you'll have that tomorrow too. No. You'll fill in based on the domain and range, so you have to be able to identify domain and range. Questions on this? All right.